Now, in this problem, we're given a little geometric arrangement here, and we're asked to show that angle Q is congruent to angle T. So we'll just go ahead and highlight these two angles here. We're looking for this angle to be congruent to that angle, and this red stuff is what we want. We don't know it yet. We only know what's given in black. But take a look at the pairs of congruent sides we have. We've got this side and this side are congruent. This side, ST, PQ, those are congruent. PR, RS, those are congruent. Let's go ahead and write that down. So that was QR is congruent with RT. PQ is congruent with ST, we'll say, and PR is congruent to RS. Okay, and each one of these we were given. So then next, that gives us the triangle RQP. So triangle, remember the order is important. RQP congruent with triangle. I don't want to mess up this order. So RQ over the 1, RT, then down the 2, this congruency, that 2 dash congruency, so that's RTS, congruent with triangle RTS. Okay. And this is by the side congruence theorem. Okay. So we've got two congruent triangles. And if these triangles are congruent, that means all of their parts are congruent. The sides are the same length, corresponding sides are the same length, and corresponding angles measure the same. Q sits between this guy, the 1, and this guy, the square, or the 2. Angle T sits between the 1 hash mark and the 2 hash mark, just like angle Q does. So that means they are corresponding parts. So we can say that angle Q is congruent with angle T by corresponding parts, commonly abbreviated CP, which is an extremely important theorem. Things like this come from corresponding parts all the time. You want to prove two lines are congruent? Show some triangles are congruent, use corresponding parts. Just like we proved these angles congruent. And that ends our proof, so I'll do a little tombstone here. Okay, and then we're on to our next problem, which is 41. Okay. In problem number 41, we're given this odd-looking shape, and we are told to show the angle ACF is congruent to angle AEB. So I'm going to go ahead and we will, again, using red here, show what we want. We want this to be congruent with that. Remember, red is what we want. We don't know it yet. Okay. So I'm doing these proofs blind, so to speak. I haven't written out my notes in advance. I'm just going to start by looking at the congruencies we were given. I had some students say that they preferred it when I did questions on the fly because it was nice to see me struggle a little bit. Yeah. So we know AB is congruent to AF. We know BC is congruent to FE. We were given this. And then that means that AB plus BC is equal to AF plus FE, which means that AC, that side, is congruent with AE. Okay, look at what we have here. I've got this length the same as this length, and then I've also got the little short sides here the same. Okay, big deal. But very important now are the right angles. If we've got a right triangle like ACF and ABE, then we just need, say, a hypotenuse and a leg, or a leg and a leg, to have congruence. So let's go ahead and let's write that down. ACF, so triangle ACF is right, and then the other right triangle that we had was AEB. I'm ending on the right angle. These were given to us by virtue of the fact that angle AFC and angle EBA were right angles. That's the blue bit here. So we've got two right triangles. We have AC congruent to AE. We have AB congruent to AF. That's enough to give us hypotenuse leg congruence. So these two triangles are congruent. ACF is congruent with triangle AEB. And recall again, this is by the hypotenuse leg congruency theorem. And then that means that, let's see here, ACF, this little acute angle, and AEB, this little acute angle. And it's the angle opposite the short side, that short leg that we had congruent. Their corresponding parts. In the order of the triangles, ACF, ACF, AEB, AEB, those letters come in the same order. So that means that they're corresponding parts. That's one of the big things to look for in corresponding parts, is the letters coming in the same order. ACF is congruent with angle AEB, but it would be not congruent with a different ordering of letters, say ABE, not congruent with a different ordering of letters, BEA. Actually, it would be in that case, because it's just these two flipped. ABE. We'll try ABE would be not congruent with EAB, that angle. There we go. So those two wouldn't be congruent, but these two would be congruent, ACF and AEB. They would be congruent by corresponding parts. Again, that's sort of shorthand for corresponding parts of congruent triangles are congruent. That's a mouthful. Corresponding parts are just CP, is a lot easier to say. And wait a minute, ACF, AEB, hey, that's what we wanted. We've shown what we set out to do. That means we're done. Okay. Good luck with these problems. They're a little bit more challenging, a bit more in depth than what we've done before. Keep asking questions, and until next time, happy geometering.